In this lecture, we discuss about the vector subspace. Let V be a vector space and let W be a subset of V. If W is a vector space with respect to operations in V, then W is called a subspace of V. There is a one theorem in which we are able to check that the given subset of a vector space is a vector subspace or not. So if we see about the definition of vector subspace, if V is a vector space and W be any subset of V, then W is a vector subspace with respect to the operations in V, then W is called a subspace of V. It means that V and W both are vector spaces and W is a subset of V. Means what are the properties of vector space? There are 10 properties of vector spaces. So the all 10 properties of vector space should be also satisfied by the subset W. Then we say that that is a vector subspace. Now, there is a theorem which states that if we only prove 3 properties of a vector space of any subset W of V, then that will be the vector subspace. So what is that theorem? Let V be a vector space with operations plus and dot, means vector addition and scalar multiplication, and let W be a subset of V, then W is subspace of V if and only if the following conditions hold. First condition is W is non-empty. That means the zero vector belongs to W. Second, closure under addition. It means for all xy belongs to W, x plus y will be element of W. And the third property is closure under scalar multiplication. It means for all x belongs to W and A belongs to R, then A into X belongs to W. So if these 3 properties are satisfied by any subset of a vector space W, then that should be vector subspace of the vector space. Let us take one example. Let V is equal to M matrix of 2 by 2 of real numbers with a vector space with respect to usual matrix addition and scalar multiplication. We have already seen this example. If W is the set of all matrices of the form W is equal to A0, 0B, where A, B are element of real number, then show that W is a vector subspace of V. So if we want to prove that this is a vector subspace, we have to only prove the 3 conditions. W will be vector subspace of V if the following properties are satisfied. First property, W is non-empty. Clearly, the 0 vector belongs to W. Since AB are real number, so if we write down 0, 0, 0, 0 is element of also W, and this is nothing but the 0 vector of the vector subspace. So first property holds. Let us go to the second property. Closure under addition. For all xy belongs to W, x plus y belongs to W. If we take any 2 example, any 2 elements, for example, 2, 0, 4, 0, 5, plus, let me take any other example, 1, 0, 0, 2. If we add these 2 elements, 2 element of W, definitely the third element will be also 3, 0, 0, 5, which is also the element of W. So we can say that this satisfies the closure under vector addition. Similarly, if we see the third property, closure under scalar multiplication. So for all x belongs to W and A belongs to V, AX belongs to W. Now let me take any element. 2 belongs to R, RB, and 1, 0, 0, 2 belongs to W. And if you multiply them, 2 into V, small v, which is equal to 2004, which is again element of W. So since all the three properties of being vector subspace are satisfied by the given set W, therefore W is a subspace of vector space V. Thank you.